You've changed the spark plugs. You've cleaned the throttle body. You've replaced the air filter. You've even thrown parts at it that your mechanic swore would fix the problem. But your car is still idling rough, still shaking at the stoplight, still hunting up and down between 500 and 1,100 RPM like it can't make up its mind. So what's going on? What if I told you there's one sensor, just one, that almost every DIY mechanic, and honestly, even a lot of professionals, completely overlook when diagnosing idle problems? A sensor so misunderstood, so frequently ignored, that it quietly destroys your idle quality, kills your fuel economy, and in severe cases, it can even damage your catalytic converter. And the worst part? Most scan tools won't even throw a check engine light for it. You'll just suffer, wondering what's wrong, spending money, getting frustrated. Stay with me because I'm going to show you exactly which sensor I'm talking about, why it causes idle problems, how to test it yourself with basic tools, and how to know for certain if it's the one killing your idle. No guessing, no throwing parts, just real diagnostic logic. Before we talk about what's wrong, let's talk about what right looks like. A healthy engine at idle should sit at a very specific RPM, usually somewhere between 600 and 900 RPM depending on the engine. On a cold start, the PCM, the powertrain control module, your engine's brain, will raise the idle to somewhere between 1,200 and 1,500 RPM. That's totally normal. It's doing that to warm up the catalytic converter in the engine oil faster. But once the engine reaches operating temperature, usually around 195 to 210 degrees Fahrenheit, the idle should settle down, lock in, and stay stable. Rock solid, not fluctuating, not surging, not dipping, and almost stalling. Now here's the first question I want you to think about. Is your idle problem happening when the engine is cold, warm, or both? That answer is a critical clue, because the sensor I'm about to talk about has a very specific behavioral pattern, and when you understand it, diagnosis becomes almost obvious. So let's get into it. By now you're probably thinking, is it the MAF sensor, the MAP sensor, the IAC, the throttle position sensor? All of those are common suspects, and you've probably already read about all of them. YouTube is full of videos about MAF sensors and IAC valves, but the sensor I'm talking about today is the IAT sensor, the intake air temperature sensor. I know what you're thinking. That little thing? Really? Yes, really. And here's the thing that makes the IAT sensor so dangerous as a diagnostic culprit. It doesn't always trip a check engine light. It can be malfunctioning, feeding wrong data to the ECU, and your OBD2 scanner might just sit there completely clean. No codes, nothing. And you'll walk away thinking, well, there's nothing wrong with the electronics, must be mechanical. And then you'll go down a rabbit hole that costs you hundreds of dollars and dozens of frustrating hours. So let's understand exactly what the IAT sensor does, and then I'll show you the science of why it ruins your idle. Do you know why air temperature matters to your engine? Think about it for a second. Air density changes with temperature. Cold air is denser, it contains more oxygen molecules per cubic foot. Hot air is less dense, fewer oxygen molecules. And since combustion is a chemical reaction between fuel and oxygen, the amount of fuel the ECU injects needs to be precisely matched to the amount of oxygen coming in. This is where the IAT sensor comes in. It's a thermistor, a simple resistor whose resistance changes with temperature. When the air is cold, resistance is high. When air is hot, resistance is low. The ECU reads that resistance value and uses it to calculate air density. Then it adjusts the fuel injector pulse width, how long the injectors stay open, to deliver the right air-to-fuel ratio. The target air-to-fuel ratio at idle, roughly 14.7 to 1, also known as stoichiometric ratio. This is the chemically perfect balance for complete combustion. Now here's where it gets interesting, and a little scary. What happens if the IAT sensor is giving the ECU a wrong temperature reading? Let me paint you two scenarios. Scenario 1, your IAT sensor has failed and it's telling the ECU the incoming air is extremely cold. Let's say minus 40 degrees. even though it's actually 75 degrees outside and your engine is fully warmed up. What does the ECU do? It thinks the air is super dense, so it injects more fuel. Your engine runs rich. Too much fuel, not enough oxygen. What do you get? Rough idle, black smoke, fuel smell, poor throttle response. In extreme cases, raw fuel washing down the cylinder walls and contaminating your engine oil. Scenario 2, the opposite. The IAT sensor tells the ECU the air is extremely hot, say 220 degrees, when it's actually a cool 65-degree morning. ECU thinks the air is thin. It pulls back fuel. Your engine runs lean. Not enough fuel. Too much air. What do you get? Rough idle, hesitation, surging RPMs, and a lean misfire that can, over time, burn your exhaust valves and destroy your catalytic converter from the heat. Are you starting to see how one tiny ignored sensor can cause this much chaos? And here's the kicker. The IAT sensor is often integrated inside the MAF sensor housing on many modern vehicles. So when you clean the MAF sensor, you might be walking right past the failing IAT element without even knowing it. Let me give you a checklist right now. Think about your own car as I go through these. How many of these symptoms do you recognize? Symptom number 1, rough or unstable idle, especially after warm-up. The car starts fine when cold, but once it warms up, the idle gets rough or hunts. That's a classic IAT failure pattern on many vehicles. The sensor behaves somewhat normally when cold, but starts reporting incorrect temperatures as the heat soak in the engine bay affects it. Symptom number 2, RPM surging between two fixed points. Your idle oscillates, let's say, between 600 and 1,100 RPM in a rhythmic cycle. The ECU is trying to correct itself, richening and then leaning the mixture in a loop because it's getting bad data. It's literally fighting itself. Symptom number 3, poor fuel economy with no obvious cause. If you've noticed your MPG has dropped and nothing else seems wrong, a rich running condition from a bad IAT sensor will absolutely trash your fuel economy. More fuel going in, same distance covered. Symptom number 4, black or dark smoke from the exhaust on startup or idle. This is the rich condition signature. Unburnt fuel leaving through the exhaust. Symptom number 5, engine feels sluggish on initial acceleration from a stop. You press the gas and there's a slight hesitation or stumble before the engine picks up. The air-fuel ratio is off at low throttle opening, where idle fueling transitions to part throttle fueling. Symptom number 6, check engine light is not on or codes point elsewhere. This is the sneaky one. You might have a P0300 random misfire code, or a P0171 lean code, or a P0172 rich code, but the IAT sensor itself doesn't generate a code unless its signal is completely out of range. A sensor that's slightly out of calibration, drifted, not dead, will never throw a code, but it'll still cause all these symptoms. How many of those symptoms does your car have? If the answer is 2 or more, keep watching, because now we're going to get under the hood and start testing. Before you can test it, you need to find it. And this is where a lot of people get confused because the IAT sensor location varies by manufacturer and engine design. There are essentially 3 places your IAT sensor might live. Location 1, inside the MAF sensor housing. This is the most common location on modern fuel-injected engines. The MAF, mass airflow, sensor measures how much air is entering the engine, and the IAT is a separate element built right into the same housing. When you look at the MAF sensor connector, it typically has 5 wires, 2 for the MAF element, 2 for the IAT thermistor, and 1 for ground. If your car has this setup, you can test both sensors simultaneously without removing anything from the intake. Location 2, in the intake air duct or air box. Some vehicles, particularly older designs from the 1990s and early 2000s, have a standalone EAT sensor threaded directly into the air intake duct between the air filter and the throttle body. It looks like a small coolant temperature sensor. It has 2 wires, signal and ground. These are easier to test and replace. Location 3, in the intake manifold. On some engines, particularly high-performance or turbocharged applications, There may be an IAT sensor mounted directly in the intake manifold after the throttle body. This measures the temperature of air after it's been compressed or after it passes through an intercooler. This is a secondary reading and is usually labeled IAT2 in the scan data. To find yours specifically, grab your phone and search your car, year, make, model, IAT sensor location. Or pull up a free wiring diagram on a site like AutoZone's free repair guides or All Data DIY. It'll save you 20 minutes of guessing. This is the part you've been waiting for. How do we actually test this sensor? You're going to need two things: a basic digital multimeter, any $20 unit from a hardware store will work, and ideally an OBD2 scanner that can show you live sensor data. Even a cheap Bluetooth scanner paired with a free app like Torque Pro on your phone will work. Test method. 1. Live data scan. This is where you start. Before touching any wires, plug your scanner in, go to live data, find IAT, intake air temperature. Now here's the critical thing to know. Before the engine starts, with the ignition on, the IAT sensor reading should be very close to the ambient air temperature outside your car. If it's 70 degrees outside, the IAT should read approximately 65 to 80 degrees Fahrenheit. If the engine has been running and heat-soaked the engine bay, the IAT might read slightly higher, maybe 90 to 110 degrees if it's a hot day or you've just driven. That's normal. What's not normal, IAT reading minus 40 degrees Fahrenheit or minus 40 degrees Celsius when it's clearly not that cold outside. That's the sensor's default value when it's open-circuited. The ECU sees infinite resistance and assumes the coldest possible temperature. IAT reading 257 degrees Fahrenheit or 125 degrees Celsius when the engine is cold and you haven't been driving. That's the sensor's default value when it's shorted to ground. Zero resistance, maximum assumed temperature. IAT reading something that makes no logical sense relative to the real-world temperature. Now here's an important follow-up question. Does the IAT reading change when you do something to it? Start the engine. Let it idle. Now get a can of compressed air, the kind you use to clean keyboards. Turn it upside down and spray a tiny burst of cold air near the IAT sensor. The reading on your scanner should drop noticeably within a few seconds. If it doesn't respond at all, that's a sign the sensor is dead or its signal wire is faulty. Test method 2. Resistance testing with a multimeter. Turn the engine off. Let the car cool down completely, at least 2 hours from last drive. Find the IAT sensor connector. Unplug it. Set your multimeter to resistance. Ohms, the ohm symbol. Place your meter probes on the two IAT sensor terminals. Here are the real-world resistance values you should see at different temperatures. At 32 degrees Fahrenheit, 0 degrees Celsius, approximately 5,000 to 9,000 ohms, 5 kiloohms to 9 kiloohms. At 68 degrees Fahrenheit, 20 degrees Celsius, approximately 2,000 to 3,500 ohms, 2 kiloohms to 3.5 kiloohms. At 104 degrees Fahrenheit, 40 degrees Celsius, approximately 900 to 1,500 ohms, 0.9 kiloohms to 1.5 kiloohms. At 140 degrees Fahrenheit, 60 degrees Celsius, approximately 400 to 700 ohms, 400 ohms to 700 ohms. These values are typical NTC, negative temperature coefficient, thermistor values. As temperature rises, resistance falls. That's the defining characteristic of an NTC thermistor. If your reading is OL, open line / infinite, the sensor element is broken inside. Bad sensor. 0 ohms or very close to 0. The sensor is shorted internally. Bad sensor. Wildly outside the range for your ambient temperature. Bad sensor. Within range. Now you need to check the wiring. Test method 3. Testing the circuit voltage. With the connector unplugged, turn the ignition on, engine off. Set your multimeter to DC voltage. Probe the signal wire in the harness connector. Not the sensor side, the ECU side. You should see approximately 5 volts DC. This is the reference voltage the ECU supplies to the sensor. If you see 0 volts, the ECU isn't sending reference voltage. Could be a blown fuse, broken wire, or a PCM issue. If you see 5 volts, great. Now plug the sensor back in and measure voltage again. With a good sensor at room temperature, you should see approximately 1.5 to 2.5 volts. As temperature rises, voltage drops towards 0.5 volts. As temperature drops, voltage rises toward 4.5 volts. If voltage is stuck at exactly 5 volts with the sensor plugged in, the sensor circuit is open. Either the sensor is bad or there's a break in the signal wire. If voltage is stuck at 0 volts, the circuit is shorted to ground. Now you have hard data. Now you know for certain. Now I want to step back for a second and ask a bigger question. Why does this sensor get ignored so consistently? Because if it's this impactful, why isn't it the first thing people check? And the answer is actually really interesting. It has to do with how we've been trained to think about car problems. When you have an idle problem, your brain goes to the mechanical side first. You think vacuum leak, dirty throttle body, stuck EGR valve, weak fuel pressure, fouled injectors. These are all valid. These are all real possibilities. Then if you go electrical, you think about the big sensors. MAF sensor, oxygen sensor, throttle position sensor. These are the sensors that get all the attention. There are entire YouTube channels dedicated to them. But the IAT sensor, it's perceived as simple. It's just measuring temperature. It's not doing any fancy airflow calculations. It doesn't have a delicate heated wire element like a MAF sensor. So people just skip over it. It doesn't get respect. And manufacturers actually make this problem worse. On most vehicles, the IAT sensor only sets a code if its signal voltage is completely outside the expected range. Below about 0.1 volts or above about 4.9 volts. But a sensor that's drifted, that's reading 30 degrees too cold all the time, consistently, will never exceed those thresholds. The ECU accepts the data as valid. It doesn't know the real air temperature. It just trusts what the sensor says. That's the dangerous middle ground. The sensor isn't dead enough to complain, but it's wrong enough to cause real problems. And here's another thing that gets overlooked. Heat soak. When you park a hot engine, all the heat in the engine block and exhaust radiates outward into the engine bay. The air around the IAT sensor can get much hotter than the air it's actually supposed to be measuring from outside. Some vehicles have this problem by design. The IAT sensor is positioned close to the exhaust manifold or close to the turbocharger. The sensor measures hot engine bay air instead of incoming fresh air. This is called a heat soak error, and it causes a lean condition every time you restart a warm engine, which, sound familiar, causes a rough idle on warm restarts. Some manufacturers have actually issued technical service bulletins, TSBs, about repositioning or adding heat shielding to the IAT sensor on specific models because of this exact problem. So if you're working on a vehicle and the IAT seems healthy, but your warm restart idle is still rough, check for TSBs related to the IAT on your specific vehicle. Now here's something that even experienced mechanics sometimes miss. The IAT sensor doesn't work in isolation. It's part of a network of sensors that the ECU uses to calculate the ideal fuel and ignition timing. Let me walk you through how these sensors interact. IAT plus MAF. The MAF sensor measures the volume of air entering the engine in grams per second. But to calculate actual air density, and therefore how much oxygen is available for combustion, the ECU needs to know both how much air and what temperature that air is. If the MAF is accurate, but the IAT is wrong, the density calculation is wrong, and the fuel delivery is wrong. IAT plus ECT, engine coolant temperature sensor. The ECT tells the ECU how warm the engine itself is. The IAT tells it how warm the incoming air is. On a cold morning, you might have a cold engine and cold air. Both sensors would be reading low. The ECU uses both readings to apply cold start enrichment strategies. If the IAT is falsely reading warm air on a cold morning, the ECU may not apply full cold start enrichment, and the engine will idle roughly until it warms up. IAT plus knock sensor. Hot intake air increases the likelihood of engine knock, detonation before the spark plug fires. The ECU uses IAT data to retard ignition timing when intake air is hot to reduce knock risk. If the IAT is falsely reading cold air, the ECU won't retard timing when it should, potentially causing knock in hot weather. If this is happening on your car, you might hear a light pinging or ticking under load and never connect it to the IAT sensor. This interconnectedness is exactly why a single bad IAT sensor can create symptoms that look like multiple different problems. You're not diagnosing one failure mode. You're diagnosing a cascading effect that touches fueling, timing, cold start behavior, and load calculations all at once. So you've tested the sensor. The resistance is off. The voltage is wrong. The live data doesn't make sense. You're confident. The IAT sensor is faulty. Now what? Good news. This is one of the cheapest and easiest repairs in automotive diagnostics. If your IAT is a standalone sensor in the air intake duct, unplug the connector. Unscrew the sensor, usually a 19mm or 22mm socket. Take it to any auto parts store, match it up by part number. New sensor is typically $10 to $30. Screw the new one in, plug it in, done. Total time 10 minutes. If your IAT is integrated with the MAF sensor, you have two options. Option 1, replace the entire MAF/IAT assembly. This is the more expensive route, typically $50 to $200 depending on the vehicle, but it gives you a completely fresh assembly. Option 2, on some vehicles, the IAT thermistor is a separate replaceable element that plugs into the MAF housing. Check your specific vehicle before assuming you need the whole assembly. After replacement, what should you expect? Immediately after replacement, your idle may actually be slightly erratic for the first few minutes. This is normal. The ECU was running with bad data for potentially months or years, and it has stored adaptive fuel trim values based on that bad data. It will need to relearn. Here's what I recommend. After installing the new sensor, disconnect the negative battery terminal for 10 minutes. This clears the short-term and long-term fuel trim data the ECU has stored. When you reconnect and start the car, the ECU will be starting fresh with the correct IAT data and will recalibrate its fuel trims much faster. After the reset, start the car and let it idle for 15 minutes without touching the gas pedal. Then take it for a 20-minute drive with a mix of city and highway driving. The ECU will complete its relearn cycle. After that drive, check your live data again. IAT readings should be logical. Short-term fuel trim, STFT, should be within plus or minus 5%. Long-term fuel trim, LTFT, should be within plus or minus 10%. If your idle is still rough after the relearn, there's another underlying cause you need to investigate. But in the majority of cases where the IAT was the culprit, you'll feel an immediate improvement. So here's what I want you to take away from this video, and it's bigger than just the IAT sensor. The lesson is this: in automotive diagnostics, the simplest sensors are often the most dangerous ones to overlook. We have this psychological bias where we assume that if something is important, it'll announce itself. The check engine light will come on, a scanner will show a code, something obvious will happen. But modern ECUs are designed to be fault tolerant. They're designed to keep the car running even when sensor data is slightly off. They compensate, they adjust, they mask problems. And that means that a sensor can be slowly feeding wrong data to your ECU for months, causing a slow degradation in idle quality, fuel economy, and performance. And your scanner will just sit there silent. The IAT sensor is a perfect example of this. But the principle applies to the coolant temperature sensor, the fuel pressure sensor, the evaporative emission system sensors, and many others. So the next time your car has an idle problem and all the obvious suspects check out, before you go replacing expensive parts, before you take it to a shop and spend hundreds of dollars, sit down with a multimeter and a scanner. Go through the basics. Test the entire sensor network, not just the famous ones. Ask yourself, what data is the ECU receiving right now? Is that data accurate? Where could there be a mismatch between what the ECU thinks is happening and what's actually happening? That's the mindset of a real diagnostician. That's how you fix cars properly instead of just throwing parts at them. The IAT sensor was the answer for a lot of you who are watching this right now. Maybe it's not the answer for all of you, but now you know how to find out. You have the tests, you have the values, you have the knowledge. And knowledge is the most powerful diagnostic tool you will ever own. If this video helped you, drop a comment below and tell me, how long have you been chasing this idle problem? What had you already replaced before finding out it was the IAT? I want to hear those stories, because those stories help the next person who's sitting in their driveway at 10 p.m. with a flashlight and a scanner trying to figure out what their car is trying to tell them. Hit the like button if this gave you clarity. Subscribe if you want more real-world car care content, and I'll see you in the next one.